Hi, welcome to Math for All, where everyone can learn more about math. I'm Denise, and I'm here to help you understand tricky math concepts that you may be confused about. Or maybe you're learning this for the first time. Welcome. Today, we're going to learn how to write a line equation given 2 points. We're going to learn 2 methods to do that. We'll note how sometimes our methods don't work with vertical lines, and we'll see how to deal with that. These concepts are usually covered in Algebra 1, Geometry, and Algebra 2, so they're really important. I have fill-in-the-blank notes for this video on my website, MathforAll.net, so go print those off so they can really help you retain this. First, I'd like to quickly summarize our steps in finding an equation of a line through 2 points. Method 1 is usually taught first, and it uses the point-slope form of a line. I'll call it the PS method. Remember that point-slope aptly needs a point and a slope to work. When we're given 2 points, we are missing that slope between them. But never fear, we have a tool for finding the slope between 2 points. That is our first step in solving these. Find the slope. y2 minus y1 over x2 minus x1. Second step is to put that slope and either of the given points into the point-slope form. Then distribute that slope and solve for y so that it's in y equals mx plus b, our favorite form. I'd say that it doesn't look like a lot of steps, but there is a lot of line knowledge that goes into solving these. Method 2 goes directly to slope-intercept form. SI method? If you're just now learning about lines, don't worry, just follow along. But if you're in Algebra 2, you are probably learning this method. Our step 1 is the same. We desperately need that slope. We use the slope formula, the difference of the y's over the difference of the x's. The second step is different with this one though. This time, we will put a point and a slope into y equals mx plus b. We have a missing variable, b, that we can use algebra to solve for. That's the third step. Get that b, the y-intercept. Fourth, put your slope and your b and bring back that x and y into slope-intercept form. I think that last step is why it's normally taught after students understand lines, as you have to know where all the information is, where in Method 1, the equation just unfolds. We're going to solve an example using both of these methods, and you get to choose which one fits best for you. Let's get going and write an equation of a line between -3,5 and 1,7 in slope-intercept form. Method 1, we will use point-slope to get there. For that, we need a point. Well, I've got 2 of those. And a slope. Wah, wah, wah. Got nothing there. But wait, all hope is not lost. I can find the slope of these points and use that. 7 minus 5 over 1 minus -3 equals 2. Over 1 plus 3 equals 4. That simplifies to 1/2. Next, we'll use point-slope form the way we learned in another video. We use the slope and our favorite points out of that -3,5 and 1,7. Either one will work. I'll pick 1,7. Putting it into the formula, I hope you can remember by heart. Y minus 7 equals 1/2 x minus 1. Our third step, put this into y equals mx plus b by distributing. Y minus 7 equals 1/2 x minus 1/2. I've got to clean this up by adding 7 to both sides. -1/2 plus 7 needs a common denominator. 7 is the same as 14 over 2. Minus 1/2 is 13/2. Y equals 1/2 x plus 13/2. That was some great work. That PS method is one way to solve these. Let's go over the more advanced way to solve the same equation. Our first step is the same as the other method. We need that slope. Well, we know it's 1/2. Now, instead of putting it into point-slope form, we're going to go straight to slope-intercept form. Using our favorite point and our slope, we'll fill in the y, x, and m in the formula. 7 equals 1/2 times 1 plus b. Notice that we are just missing the b. We use algebra to find it. 1/2 times 1 is just 1/2. Subtract 1/2 from both sides to get the b by itself. 14/2 minus 1/2. We're back to that 13/2. I feel like this is the trickiest part. Put the m of 1/2 and the b of the 13/2 back into the equation, bringing back the x and the y, for y equals 1/2 x plus 13/2. I hope you were able to follow along with those examples. There are a few special cases to this rule: horizontal and vertical lines. Say they give us this one. Find the equation of the line through 0, 4, and 5, 4. Regardless of the method we choose, we find the slope first, so let's do it. 4 minus 4 over 5 minus 0 equals 0 over 5, which equals 0. We are allowed to have 0 divided by a number, so it's okay there. I'll choose method 2 using that slope-intercept form and put this into y equals mx plus b. Choosing the point 5, 4. I have 4 equals 0 times 5 plus b, for b equaling 4. Then the equation is just y equals 4. You could notice that in those given points, the y values don't change. They're always 4, so you could have just said y equals 4. But maybe as we're doing a bunch of these, you may not have noticed that right away, so we could solve it using algebra, no problem. And remember that y equals 4 is a horizontal line. Here's the second special case. Find the equation of the line between -3, 1 and -3, 5. Assuming that we don't notice that it's special, we'll start by finding the slope. 5 minus 1 over -3 minus -3. 4 over 0. Auga, auga! Thou shalt never divide by 0. It's undefined. Your calculator may say math error. It's just all around trouble. We cannot put in anything for our slope then. You need to remember to abandon all of the methods that I just talked about and notice that the x's don't change. They are both -3. So the equation is x equals -3. Another way to look at it is that vertical lines are the ones that have an undefined slope because we can't ski down it, and their equations are x equals a number. Way to go! You have just learned how to find an equation of a line through given points. Now, some of yours may have fractions or negative numbers for the slopes, but you solve them the same. If you feel like you need more practice, watch my video on finding line equations of parallel and perpendicular lines, as we'll use these techniques there too. If you're feeling good, please go to my website, MathforAll.net, and print out a worksheet where you can practice some of these using whichever method is your favorite. Then come back to learn more about math.